So in this question, so what is the normal energy capacity in watt hour of 2P80S battery pack? So 2P80S. So 88 stands for the 80 cells are connected in series, and 2P stands for that the number of the 80S parallel combination. So the circuit would be like this. So here, so number of cells that is connected in series, it's 80. So 80 cells are connected in series, and there are two modules. Such two modules are connected in parallel. So two parallel. So now see that the capacity of each cell is 50 ampere hour. The nominal voltage is 3.8 volt. So the voltage of each cell is 3.8 volt, and the 50 ampere stands for the IT is 15 ampere hour. Now the energy of each cell. So what is the energy of one cell? So energy of one cell is voltage into current into T. So voltage is 3.8, that I into T is 15. So this is the value of the energy held by a single cell. Now we need to calculate so what is a nominal energy capacity of the pack, complete pack. So total cell in that pack is, so two parallel 80 cells are connected in series, so 160 cells are there. So this is the energy that is stored by a single cell. So what is the total energy is 3.8 into 15 into 160. So try this answer, you will get the total energy stored by the pack. So in the second question, if you see that the pack formation is 8P100S. So 8P100S, the 100 cells are connected in series connection, and similarly 8 of such modules are connected in a parallelly. So this is 8 number of modules are connected parallelly, and 100 cells are connected serially. Now how many cells are there in each module? So this is a single module, and if you can see that the total cells are the product of the number of the parallel path and the number of cells in each path. So the answer is 800 cells. In this question, if an analog to digital converter has an input range of 0 through 5 volt, 0 volt through 5 volt, that is a range of an instrument, and it has 12 bit of precision. So the precision is 12 bit. So what is the resolution of the converter in millivolt? So the expression for resolution is the highest voltage minus the lowest, all divided by 2 power. What is the precision? That it's a 12 bit, so 2 power 12. So this is the answer of the resolution of this instrument. So when we are coming to that the fifth question of the week 3, the question reads, if an analog to digital converter has an input range of 0 volt through 5 volt, so the converter, the measuring the range is 0 to 5 volt, and it has a 10 bit of precision. So precision is a 10 bit precision. And what is the maximum quantization error? So before we are moving to the condensation error, we need to find what is the resolution. So once we find the resolution, then it is very easy to find the condensation error. So resolution is, so the highest the voltage minus subtract the lowest by 2 power 10. So this is the resolution. Let us take it as an R. So then what is the condensation error? So condensation error is plus or minus R by 2. If R is 5 volt, then the 5 millivolt, then condensation is 5 millivolt divided by 2, that is 2.5 millivolt. Here you can see a voltage divider circuit, and the question is you need to find what is the voltage V, that is voltage across the 1 ohm resistors. So here we can see that a 5 voltage supply, and you need to calculate what is an I current flowing through this the series resistor element. So the current is, what is the total voltage, that is 5 divided by the 2 resistors. So the 4 and 1 are connected serially, so this algebraic sum 4 plus 1. So the current is 1 ampere. Now what is the voltage across the 1 ohm resistor? So the voltage across 1 ohm resistor is the current, that is I, into that resistance, that is 1. So I is 1 into 1. So voltage across 1 ohm resistance is 1 volt. So in this circuit, consider a 0.1 milliohm the current sensor shunt connected by an amplifier with a gain factor of 200 to an analog to digital converter. So if you see that there is a shunt resistors, so there are some element before that, and the value of this shunt resistance is 0.1 milliohm, and from which a voltage is being sensed, and it is fed to the analog to digital converter after an amplification of 200. So finally the value of the voltage to the A to D converter is 4 volt. So the 4 volt is that after amplification. So before amplification is the 4 divided by 200 is that is the voltage before the amplification. So this is the voltage across this 0.1 milliohm. So just we know that the voltage is current into resistors, and the question is what amount of electric current is passing through the shunt resistor. So you need to calculate, you need to find what is the value of that resistor, that is a current that is passing through this resistor. So here, using this basics Ohm's law equation, we can identify the value of current that is through this the shunt element. So here the voltage, we know that voltage that is acting across the shunt element is 4 divided by 200 equals, so the I is an unknown factor into the resistor. Resistor is 0.1 and 10 power minus 3. So I obviously 4 divided by 200 into 0.1 10 power minus 3. So if you use the calculator and find the value of current. So the 11th question reads that consider a battery having VB. So VB is 350 volt. What is the minimum value of isolation resistance in kilo ohm for the battery pack to be considered safe? That the isolation value of the isolation resistance R is VB divided by 2 milliampere. So this is the value of R considered to be the minimum value for the safe operation of this battery pack. Now if you substitute this 350 divided by 2 milliamperes, so just 2 milliampere is 2 into 10 power minus 3. So just use your calculator and find, so what would be the value of R. So in this questions, if you read through this the question, you can find that the fault on the high side. So if the fault is on the high side, then the the expression for the isolation resistance is R naught divided by the V2 dash 1 plus V1 by V2 minus V2 dash. If you look through this passage, you can find that so we can find the value of R naught. So R naught is given, that is 150 kilo ohm, and V2 dash is given, that is 70 volt, and V1 is given, that is 160, and V2 is also given, that is 140. And if you substitute all this into this given expression, you can find the isolation resistance on the high side. So that is the end of the week 3.